this. Okay, you guys can see this? Okay, cool. So I'm going to start us off kind of similar to what we did last week in the sense of partner, like feedback from people. So GitHub, you've heard it thrown around. You've heard it thrown around. Probably with us nerds that do the coding. Never heard of GitHub? That's good. Me neither. So what the heck is GitHub? Who knows? What are some like words you've heard associated with GitHub?
Pain and suffering. Code.
Code?
Oh, it's answer.
What else? That's a good one.
Like shareable projects.
Shareable projects?
Version control.
Okay. Kind of going off of that, Nick, what I think something that ties in is just this syncing feature, the ability to sync items back and forth. And that pretty much covers it. So the misconception with GitHub, so it was designed for code. It is designed for code, but you can store, in theory, whatever you want there. So it's kind of like OneDrive. In very, very, very simple terms, it is just OneDrive, but for coding, like specifically tailor-made for coding. And what that means is you get all of the same features as OneDrive. So it's cloud storage. So you can upload files to it. Like when I was a sophomore, I accidentally uploaded the entire, like everything I had on Wi-Fi related stuff, just that whole folder on my computer, I just uploaded to GitHub. And it was like way bigger than I only needed like a couple lines of code, but you can upload whatever you want to GitHub projects. So instead of being geared, so in normal OneDrive, we're gonna do just like a high level overview of GitHub. And compare it to OneDrive. So we have OneDrive, right? And then we have GitHub. How bad is this going to be? Okay, we have GitHub. So for OneDrive, you have your OneDrive, and then you have like little folders that branch off from it. This is really bad. And you can put files in folders, right? And so how it works with GitHub is you have a GitHub account, but there are different projects. And so say you're working on one code thing. I don't know, I'm making this a gear, just a really bad gear because I'm drawing it while I'm talking. So say you're working on a mechanical project. You can separate them kind of like folders, but they're projects. And then within each project, you have folders, right? So these projects that you can do, where you can house, like, it's more just to kind of separate out how you're thinking, more of like groups of folders, like different categories. These are called repositories. Okay, so these are called repositories. All a repository is just a big place. It's like a section where a whole bunch of files are stored. So we have a code repository for Wi-Fi. We have a separate code repository for the command board. We have a third code repository for the power sense. And also, like I said before, it's not just with code. So we also have a code repository for the power sense, for the PCB design, not just the code. We have one for all of our boards have a PCB design repository, a code repository, and then some of them, like our website, have back-end repositories as needed. So it's separated. We have, so collab, this is the user account, and it currently has 17 repositories or repos. So that's similar to OneDrive. Think of it as like OneDrive, but it's separated, it's organized a little bit differently. And I'm going to explain what makes it cool, but in order to do that, I'm going to give you guys a little bit of a history lesson. Okay, and Dr. Fish is listening, so I'm going to avoid using dates because I'm not completely sure when all the dates happened, but I do know the story. So once there was a beautiful man named Linus Torvalds. And raise your hand if you know who that is. Okay, David got me. Ben, do you know who that is? Okay, so Linus Torvalds, I believe, don't quote me on this. This part isn't important. I believe he was either an Apple executive or developer and left, or he was just a guy that was really crazy about Apple. And what happened was, he was definitely working for Apple. He started an interdepartmental, basically he was trying to develop on Apple products, and he was like, hey, we do so many different things in all the labs, like it would be nice, like everybody has their own little code that they're running, it'd be nice if we just had one kind of collection of all of it, and it would be kind of like this thing that you could just like access and run people's lab code that you write, or you could write your own and submit to it, and then it would just all be great. And does anybody know what he called this? He called it Linux, after his first name. And so what happened was people started using this and just kind of feeding their own scripts to it, and eventually somebody really liked it, but they got a new computer, and so they had to write drivers for it so it would run on a new computer, and then somebody wanted it to work on this thing, somebody wanted it to run on this, XYZ, somebody wanted to put it on a microcontroller. And fast forward 7 years, they actually integrated it with Apple. So it became a huge, became able to be run on Apple, and it was a version of the Apple operating system. So Linux was actually a version of the Apple operating system. And this is back in I want to say, I said I was going to avoid using dates. This is very early on in the computer career. This is like the era when the Big Macs with like the big blue butt would come out of them, and there was like the keyboard, and they were like semi-transparent. It was like those days, like before those days. And what happened was, Linus Torvalds really didn't like the direction Apple was going. Apple was privatizing the industry, and Linus Torvalds believed in open sourcing everything. Because his whole project was community fed, tons of success, and so he thought, like, if you really want innovation, that's the way to go. So what he did was, he did something called a fork. What that is when you have something and you branch it in 2 different directions, and you have the same base model, but you have 2 different outcomes. So that's called a fork. It's a fork in the road. So these branches off of the fork, if you follow me, it's a branch, so it stems back to the root, off the same base, but they look different. You follow me? So 1984, Linus Torvalds forked the Apple operating system, which I believe then it was really old. I don't know what version that was because I don't care about Apple enough. But he named this new version and got permission to open source Apple's operating system. So basically, it would be something totally different, but it would be free and open source. And if you wanted to contribute to it, you could. And it would be community driven. And that is what the Linux operating system is. So fast forward like 25 years, 30, oh my gosh, 35 years. And along that way, so that's what the Linux operating system is now. And also Android is part of that. And on this way, so you have, Linus is now facing the problem of thousands of people want to all contribute all at the same time and to try out things and still go in and try out their code that they wrote on their Linux operating system. How do you get all this process going on? So Linus Torvalds wanted to create something that, so back to say, the App Store didn't exist yet. You gotta understand, this is before iPhones, before all that. App Stores were not a thing. He pretty much wanted a way where everybody could upload their own code, and Linux computers would have access to it, and if you wanted to test your own code on a separate computer, or you wanted to tell it to a friend, or Linus was developing his own software that he wanted to test out with a whole bunch of people that for like beta testing, all that stuff, he wanted it to be really easy and all in one place. And he named that GitHub. So that's what GitHub is. So for you guys who aren't aware, anything you upload to GitHub, if you have a Linux operating system, it's on the App Store. Anything you put on GitHub is published to the App Store. And the App Store looks very different, and it's not advertised anywhere or it's not publicized anywhere because there are like millions and millions and millions and millions of projects on GitHub. And so it's not like people are going to steal your stuff, but it is the App Store for Linux. So what that means is this website that we're developing on, we're going to deploy it on a Raspberry Pi, which runs Linux. So we can convert a GitHub project to an application to run on Linux with the click of a button. And then when we go to PCZ, instead of emailing them over the whole website and all this, that, or what, they literally will just like go install EMMS website, and then it'll do everything else. So that is the original purpose of GitHub, where you can just send stuff and then deploy it elsewhere. Nowadays, way on top of that, everybody good, I just want to stop there. Everybody understanding GitHub. That was kind of the inception of why it was created, why we use it, why it's different than OneDrive, because that was the purpose that it was meant to fulfill. To collab, and then pretty soon after, this idea of collaboration, where we want to do this, but we want to work together. And we have the ability to work together, and what Linus wanted was multiple people to be working on it at the same time. And what he did was every file on GitHub, so we're going to go with a text file, okay? So say I have some code here, and I've written code, and say this is Wi-Fi code for the meter, not Wi-Fi. This is Wi-Fi code, right? And then say down here I know this is really, really kind of a unique use case, but it happens. And so say this is database code, right? Or say Ben and I are both working on the command board code, and I'm working on getting the SPI right, and Ben's working on mass power failure. It's the same file, but it's different parts of it, right? And so what GitHub does is if GitHub, it's called tracking changes. So it knows the original and it knows the current. And it knows that Ben has been working on just this part of the file. And so if Ben saves and does something called push, he uploads to GitHub, he syncs it with GitHub. Because I've only been working on this section, GitHub knows that and will auto update this section for me.
It basically says, oh, Ben changed line 172 from this to this.
Yep.
Whenever that goes to the next version, just do that change. And so if he's working on line even 171,
yep,
then that's fine.
It's fine, because it's not just about files, it's things within files.
What happens if you like still happen to change the same line of code?
Yes.
And then like what did you update?
So you can turn off automatic updating, and by default it is off, and actually don't recommend it for that specific purpose. You have to, so this will probably be good. So there's two main things you do when you're working with GitHub. If you want to, what's called pull, so if you want to develop, which I believe Katie and Zach had to do this very recently. So if you want to pull it, so you want to download stuff off of GitHub, you select the repository, and then remember what I was talking about, this fork? So you select your repository, so maybe that is the Wi-Fi code, so it's Wi-Fi code, and then you want to select your individual thing you're working on. And you can name these, and you can also have as many branches as you want. So you're saying, hey, this is the root thing we're starting off with. I'm going to add to this. So for instance, when I made the Wi-Fi, I took the communication from the command board and built upon that. And if Ben's working on a bug and I'm working on a bug, we usually separate, finish the bug we're working on, and then recombine in what's called a merge. And we merge back into like some weird combination of the two. Or the three. Does that make sense? Yeah. So every single step of Yep. Yep. So if we're both working on the same branch, it does this every time you want to like save your changes. And if you are working on different branches, when you merge, it does that. Does that make sense? Yeah. And then, so if you're working in your own branch, obviously you're the only one making changes, so it's not going to see any problems. But when you go to merge, if somebody else has made changes or your changes collide with here, so if you're adding things, if you're only adding things, technically you're not changing anything at the root, so just do it automatically. But if you're changing and modifying the root branch or the root repository, then it will ask and throw errors and say, hey, which one do you want to keep? And I'm going to show you that at the end today. I'm going to try to merge my Wi-Fi code back to main. So when you make a new repository, you create one new repository and one branch, and that branch is called main, and that's your root. From there, you can fork it to multiple branches and merge and do all that kind of stuff. But I know I'm hitting with a lot of new terminology, so I recognize that, and please ask questions if you need to clarify. So what it looks like, to give you some of the words, is if you want to download, so this is downloading code or downloading a new branch, whatever. If you need to pull in the latest stuff, so this is like syncing. So you pull in code, right? And mind you, on GitHub, I'll pull this up and show you. It's just one button and it just changes what it does every time you click it. So if you want to do all this, you just click 3 times. So it's just, you don't even know you're doing it half time. But this is what it does. So you first pull the code, and that's it. That's all you do when you want to download stuff. That's literally it. But when you want to go up, so first thing you do is you commit your changes, which you're saying, hey, I'm done. This is a stopping point. This is a set of information. That can be whenever you want. Like I said, every single step of this is manual. So this is, mind you, a commit is local to your computer. Okay, so I'm working on some stuff and I just want to save it on GitHub, different than like Eclipse or whatever you're programming. I just want to save it on GitHub, marker for GitHub. I still need to work out these bugs. Or I worked on these bugs, it's all done. Commit it, saves that kind of time receipt and all these comments to your local computer. And something interesting with a commit is you have to have comments. You can't commit nothing. You have to put a reason why you committed. There's a text box. You have to put why. So when you commit that, it goes to local, and you can do however many commits you want before you do something called a push. And when you push, it syncs your branch to the cloud and runs this. And so if you're the only person working in your branch, because you're only adding stuff, or it's just you, it knows that and will just make the changes. But if Ben and I are doing it, if I push first, obviously I'm the first person to push because all the commits are local, it doesn't see Ben's changes yet. So it just does mine, and then if Ben pushes, it says, whoa, hey, Zach already made his stuff, but you had some changes that it knows everything. So it's very intelligent. So you push that, and if there are problems, this is the step in which it will throw errors. The really suck part about the desktop application for GitHub is that you can't fix these on the desktop. You have to go online because it is natively a cloud website-based application. They're lacking in their desktop. But I'm gonna walk you through that, and then what that does is that syncs that sucker to the cloud, and those changes can then be pulled by other people. So I think Nick probably has the most recent example of this is when I was setting up a new repo for the Wi-Fi code. You didn't have the new changes that I made, and so I clicked it a push, and you clicked it a pull, and it got the changes popped up in your Eclipse. Something really cool is because GitHub has been around for so long. This is an aside, and then we're gonna actually dive into like GitHub. There's a whole lot more features. GitHub has been around for so long. It's actually been around for before a lot of modern programming suites. So like things like Eclipse, things like Swift for Apple, things like Python even. It's been around way longer than Python. And a lot of these softwares and these editors to code in, like Android Studio, IntelliJ, all those, are built with integration for Eclipse, or integration for GitHub. So if you're coding on GitHub, you don't even have to have the Eclipse, you don't even have to have the GitHub application. In theory, if you really want to, in Eclipse, you can pull in a branch. You can pull a repository from GitHub, all from Eclipse, and commit and do all that stuff just staying in Eclipse. We don't do that because it's super complicated and different for each application we use, which is much easier to do GitHub Desktop, because what GitHub Desktop does is just like OneDrive, it just pops a folder on your desktop. Or actually, in your documents folder, pops a folder on your computer, and then you edit from within that folder. Does that make sense? Okay, cool. So GitHub Remember, it's been around for a really long time. So those are just the very, very basics of what it can do. What are you smiling at? You think it's funny? Maybe. I like, yeah.
It reminds me of like you're like only
Yeah, because it's not the fun part. The background isn't the fun part. The playing around with it is the fun part. So I want to warn you guys all ahead of time. I mean, you saw me sitting down and grabbing a mouse. So if this is dry, please tell me. Like, seriously, please tell me. Because my goal is just to help you guys learn the software and give a cursory overview. And Dr. Fish, if you're watching this, that you can like, oh man, hang on a second. I really hope that Dr. Fish can hear me. Yeah, we're good. But my goal is to just make sure that everybody has kind of a general understanding. Oh, yeah, screen sharing stopped because the sharing window has closed. Let me just share my whole screen. Yay, now you guys can see me. I was Googling this. So actually, we're going to start with just GitHub. So we have a collaboratory EMMS account, okay? And because there's a lot of students that come in and out of the projects, the repositories, it's like a team. So it's hard to explain. Let me just show you guys. It's like the project page, yeah. So I'm signing into my personal account, but I can go to the Collab EMMS. So this is Collab EMMS is a user, and it is also a project. And so I feel like I need to rewrite the hierarchy of all these different words that you guys are hearing, because they all kind of sound the same, like repositories, projects, branch, all kind of sound the same. So you have a project, which you have a project. What's inside of that, you have repositories. You have repos. And then from within those, you have branches. And this is where all your files are stored. Your files, different files are stored in repos, and you can have like forks. You can have like this fork merge with this fork and come together, and then branch off, and this guy comes here, and then you abandon it and come down here, and then take this guy and go up this way, and come down, and then this guy merges with this guy, comes back, like crazy stuff like that. With all these like branches and changes, and GitHub tracks all that. And then as you're developing, it should look like this. It kind of looks like a tree, and there's actually websites you can go on where you can see it, like visualize it. This is Collab EMMS. There's a user account that has created this project and given every one of us administrative access to well, actually I did that at the beginning of the year, but we all have administrative access to this project page, which means though we did not create it, we can have full access to it, modify it, all that kind of stuff. So I lied. It's not 17, it's 20 repositories because of the website. We added 3 for the website. The pinned repositories, I put this here. So I mean, Ben can test this. I'm pretty sure I'm the only really one that uses this frequently. So I wrote everybody's case last February and March to like do repository stuff, and it worked well, but I got worn out from writing everybody's case. But when you use this, it works amazing. And we haven't really done a lot, like a lot of us haven't been coding at the same time, so it hasn't been a huge deal, but you will see that it's very nice. So we dive in, so these are our repositories. It's just a list. So we have a naming syntax to help understand. So it's just our EMMS, and then either code or PCB, and then the name of that. So there's a breakdown. So like code, PCB, I think we have like a prototype, yeah, test. And then everything after a certain point, there's this PowerSense 3.0, we should get rid of that because it hasn't been updated in a while. But if I go here, I'm trying to think and see what a good example would be. We're gonna do, just to give an example. Command board? All right, we'll do the command board. So if you can see here, it auto figures out what the main language is. So a lot of these are either C or Java. You said command board. Oh, PCB, thank you. Code, command board. Ah, thank you.
So this is now, we're in a repository. So this is what's inside the repository. So I can go click, and these are all the files, right? Follow me? So this is just like OneDrive. It looks a whole lot different. And if you notice, it is like monstrously faster. It's so much faster. But I can even go in and that's like .c file. So I can go in and actually look at this file, right? So I can go down and look at each individual file, and I can actually edit it. I don't know why the heck you'd want to edit it if it's like a programming code online, but you can. So that is like a deep dive into actually, like we've established, you can actually go in and you can modify and look at the files. And if you see here, see how it says 35 commits? You can actually go in and see all of the different times people have commented on stuff. And remember how I said you have to comment what you did? So then we'll do xsum update, baby. So here you can see the bad checksums are thrown out, and the checking xsum didn't clear if the buffer checked. You guys can read. I don't need to read this for you. So on the left, you see the old, and on the right, you see the new. And green is what was kept with the changes. So you see the little plus symbol, and you see the little minus symbol. So it's crazy when coding and doing all this. You can see the add stuff. So you get very, very in depth. It remembers everything. And these are only showing the changed files. I feel like I'm boring myself. So we're gonna kind of speed this up a little bit. Does everybody understand that? Okay. And if you see here, see how it says master? Yes.
So like each of the like when you're talking about personal all that stuff, like you're saying that all those are under like I guess what I'm saying is you can access computers from GitHub.
Yeah, so Eclipse, IntelliJ, Swift, Swift is the language for Apple, but whatever IDE. So there's something, I guess maybe I should talk about this. So all those names that I just named, they're called IDEs. Okay, so David, what's an IDE stand for? What does IDE stand for? Is it integrated or interactive? I thought it was interactive. Integrated? Okay. What? Can you Google it? I'm pretty sure it's interactive. It is integrated? Yeah, that's really wrong. Okay. So integrated. Or it could be international development. Okay, so what an IDE is it just makes coding a whole lot easier. So, like, have you ever used Eclipse? You use Eclipse, so you know that's Eclipse. Arduino is, yeah, Arduino IDE, that's an IDE. It's pretty much like an editor where you are able to like modify the text file of code and run it in the same application. Yeah. It gives you error checks, yeah. What's up, Caitlin? MPLab is an IDE. Yeah, MPLab is an IDE. So I'll walk through that. Don't worry, I'm walking through that. We gotta understand everything that's happening here before we can. This is all foundation stuff. So you guys can see here we have our branches. So these are all the different things being worked on. And again, like I said, we have our master. So our master is our marker. For instance, if we go to Tom testing, you see this branch is 22 commits behind master, which basically what happens is we have our master and we had stuff coming off of it and we did different things, and then all of a sudden somebody's like, okay, like we have a new master. We're gonna throw away this old guy. All these updates now make a new like final foundation, and then other people build off of that. You know what I'm saying? So we have new iterations of this master branch because our master is like our final thing we want. Like ultimately when we're done with everything, all the branches are merged back into master. And we've done that before. A while ago when I was a junior, one of the huge problems we had was Ben was working on last power failure, Nate was working on checksum. All the boards were being updated constantly on different things, and we just needed version control and merging everything with master when we're all done. So that being said, you can look, you can swap to a different branch, see the differences. So you still get the entire repository, but just with the changes. For instance, Ben's interrupt changes. We can see all of these. And if I want to, I can just download a zip file of it. So I can just download a zip file, get those changes. But that doesn't take advantage of all the syncing features and the amazing things that you can do. Because if you notice, there's a download button, but there's not an upload button. The only way you can upload is through IDEs or the GitHub desktop application. So we're going to do that quick, and then if we have time left over, I'm going to talk about the issues tab and all these different things, because from an administrative standpoint, those are just as important. So GitHub desktop, I'm going to launch it, and it's an application. So it's a desktop application, Windows, Mac, and Linux. Obviously, it's Linux. And what I can do here is, to give an idea, I can now edit repositories and branches, and I can send them back up to the cloud. So here, if you can see, I have the repository EMMS code user interface Java backend. So Java backend. And my current branch is Zach Wireless. So this can be like, see, there's a main branch. So I have a fork off of the main branch where I want to work on the wireless stuff. And Bennett has one where he's going to work on the database stuff. Follow me? And then when we're finished with our things, we'll merge them back to main, and then we'll have a new thing, hopefully, with both. So I pick my repository, pick my branch, and then I fetch, which is something that I think I forgot. I don't know what there is. No, I said pull, but it's the same thing. So what I can do is I can show this in Explorer, because it actually downloads it to a physical place. So if I go, so my physical storage location, so these are now files on my computer that match this. So let's see. Let's go to Zach Wireless. You see bin, src, class path, you see that's the same thing. If I go into the src folder, see that's the same thing. So that is synced. Every time I click fetch, it syncs. And what I'm going to do is if I open Eclipse, which Lord help us, it's going to take forever. For any of you guys who use Eclipse, it takes a little bit to open. But I can then open an editor in this folder and point it to this folder and start developing from the folder, and all the files I change will show up. So something cool is, I don't want to do this, but so if I delete this wireless folder, that hurts. I don't cancel that. I don't want to do that. Everything's frozen. You still have the wireless folder? Uh-oh. There you go. It's back. Back. Poof. That was a bad example. So, so see how this is blue? And the EMMS code, see how this is blue? That means that it knows it's GitHub. So there's a hidden folder called .git. I don't need to explain to you, but it knows it's GitHub. And say, for instance, we go in here. Oh, yeah, I'm already in. And say I add a comment, live demos are difficult. Okay, that'll show up. See how it just showed up? So it knows in meter Java, I added live demos are difficult. And what I can do is summary. I can write a summary and say EMMS workshop. And then I can put a description, test to show GitHub works. Okay, cool. Commit to Zach Wireless. So I have now committed that. And remember what I said, that is local. And I now push the origin to the cloud. So what that does is that takes my local changes, pushes it to the website. And if I would like to merge it with main, I create a pull request, and then it starts merging the changes to main. Now, because everything that I've done has just been adding, it says it's able to merge without having to go into the file editor. However, you can, yeah, so here's all the changes and additions made. there's a whole lot in here, and I am just doing a very summarized general overview. So I'm going to talk really fast for a second, and hopefully that will answer some questions you may have. Number one, there's a lot more than just .java. There's a lot more than just Java files when you're in a Java application. So GitHub intuitively knows what Java files are edited files and what Java files are dumb things like your doc type or your class path for like website stuff. So it ignores things that change like cache and all that kind of stuff, and only keeps the stuff that it thinks are relevant information, which you can set and change in the settings. So stuff like Java and Eclipse files and projects, it just intuitively knows that because it's just crowdsourced, and everybody knows that like it looks a certain way when it's a project file. However, you can go in and change all that. Same with MPLab. So what I would do is if I was coding in MPLab, I would switch to the PowerSense code. I would pull the current branch of active power calculation, which as you can see, I should probably make a commit because I haven't committed. And then what I do is I can view that. Oof, there's a way to view it. No, where am I teaching? I can show and explore. So this is where my current sense project is, right? So I swapped branches. I swapped repositories. I'm doing something totally different. It put the files on my computer. And now when I open up MPLab, so this project is still there, however, it's not active. So now if I open up MPLab, I have preset MPLab to operate with GitHub, but what I would do is I would do file import project and then point it to the folder of the installation where GitHub dumped the files. Does that make sense? Does everybody understand this? And I can like Zach stop explaining, go on and move to other things with like just kind of how GitHub works. Yeah. Making sense to everybody? Okay, cool. It's a very simple concept of just like it syncs stuff, but it's a little complicated to see in action. And there is some really cool stuff that hopefully you can learn from. So like I said before, you can just like you can do file import and then so you can open a project whenever it wants to load. And one of the options when you open a project is to open it from GitHub, and you can actually sign in through MPLab. And basically, Dr. Fish, if you're watching it, I believe that's what you guys did. I did that my sophomore year for MPLab and with Eclipse, and what I found is that it just really sucks. Like not Eclipse, but GitHub integration just really stinks unless you use GitHub Desktop. I just found like GitHub Desktop, it's universal. It just puts files on your computer, super easy, all that kind of stuff, super easy. As we're trying to like manage it with MPLab and Eclipse is a little confusing. To me, at least, it's confusing. I couldn't like figure it out very much. Yeah, so that is like basics of how we're supposed to use GitHub. So in theory, you should always be able to grab the latest version of whatever we're working on. And if you're developing on it, I had gotten people into the routine of updating at least weekly. So just whatever you're working on, just Thursday, end of collab time, you commit to GitHub, just whatever you have. So that other people can kind of track and see what you're doing, gets you committing, gets you in the habit of just kind of like saving and pushing to the cloud, because if something happens to your computer, you lose all that stuff. We don't have enough coders, like hardcore coders, to do that, and the website stuff's already stored on the Pi, so it doesn't make sense to like try to do it through GitHub. But that is that. So I want to then kind of shift gears with the last 10 minutes here and focus on some of the additional administrative features on GitHub. It's administrative, but it's for you guys to see. On GitHub, you can track and see how far along we are. So our progress to getting PCZ back up and running is actually visible on here, which is kind of cool. So does anybody have any questions with like how we're doing GitHub, how it all works, the terminology, anything like that?
Just briefly go through like, hey, I'm starting a new project, or like a new part of the project.
A new part of the project? Yeah. So what I can do is I can either make a new repository, or I can add a local one, which is, I'm not exactly sure when you would use that, so I apologize, but that's if you have a repository on your computer, presumably from another project. I don't know how it would become like unlinked. Or you're starting something from scratch, you want to do a new repository. Or you can do this all from online. So actually, let's do it online. That's probably what people are going to do. So I'm Zach Halsinger, and this is my user profile, and you can laugh at it while I tell you about stuff. So as you see, I did one commit. I want to show off my 2019. Yeah, baby. So I want to start a new repository, right? As I did my final project, I did some other stuff. I want to start a new guy. Repository name is workshop, right? And you can't make it, oh, you can make it private. You used to not be able to make it private. So a git ignores what I was talking about before, where you can have it ignore and not track different things and just ignore changes made to certain file types. You can also choose license. So if you have a copyright on what you're developing, you can change all of this. So like I believe the website would use an Apache license. We're gonna leave it unchecked because I don't really care about that. So yay, we have workshop. So I can actually add a file. So I guess I can't upload. So I apologize for that. But we're gonna upload stuff. So we are gonna upload an EMMS report. Commit changes. So this is a repository, right? So this is just one thing, one little thing. It's not a project, it's a repository. So now, instead of just having a README, we have a project record, and we can go and view the raw Word. We can view the raw Word bytes from that. But I don't want to just download that. I want to modify it. So what do I do to modify it? I go to my GitHub. I'm signed in. This is assuming you're signed in. I can look at my repositories and be like, ooh, I don't see it here. I'm going to clone the repository, which means I'm going to make a copy of it. And I'm going to scroll down until I see Crouton Workshop. And I'm going to clone that bad boy. And so what should happen is if I show this in Explorer, boom, there it is, EMMS project report. So say I open this, and I'm just going to brutally ruin this document, just a heads up. Is this it? I'm scared that that's not the right one. I'm going to reopen it. Yay. So I go through and I just go, project reviews are dumb, and I save it, okay? So obviously that's a little bit of a change. So if we see on GitHub, I modified it. Yay, I changed the file. So changed it. So I'm gonna close out of this. I am ready to update and show my boss that I did such a good job. So I'm gonna say as a summary, project bug fixes. Say fix the problem with PRs. And then I commit that. And then I push that because it's a local commit. I now want to push it to the cloud. Yay, follow me. So this can be, so say I want to actually do like a coding thing. Rather than just uploading a whole bunch of files to begin with, I create an empty repository, I clone it to GitHub desktop, open it in Explorer, and then when I make a new Eclipse project or whatever, I just have it saved to that location. Does that make sense? And that is all, oh man, I didn't mean to bump that. That is all that GitHub is. It's just this syncing back and forth. And some of the cool administrative stuff that aren't necessarily repository stuff is if we go to our organization. So notice that I can create a new repository. This is just the owners, it's within the collaboratory ownership instead of me. Everybody catching that? And I'm allowed to do this because I've been deemed an administrator, and you guys are as well. So if you look over this tab, we have the packages. Packages would be if you want to actually download it to Linux, like actually have it as a downloadable application that they can just install. People is everybody that's on the team. This is people who are obviously currently, Sam, I'm calling you out, currently on the GitHub page. I like your dog, by the way. And we also have my friend Matthew Deers, who was the reason why I joined EMMS, who has not been, I don't think he's ever actually done anything on GitHub, and he hasn't been on the team for 3 years. But yeah, there's just everybody. I don't know who J Money is. So we have a team. We don't use teams, but I just put everybody in this team. because it was there. Big thing is projects. So we have Nate Nation, and this is a way to track our bugs. So what you can see here is bug list. And what this is a summary of all the bugs that are a problem with our meter. Counterintuitively, the red means it is fixed. And if it's not fixed, it's green. I don't know. But that's just the way that it is. If you close it, it's red. GitHub made that decision. So what this means, yeah, I think that's what it's meant to say. I don't know why it's red. So what I can do is say, see, I pushed one 11 minutes ago. Say I go to, actually I should do this. Say oopsies, last one. So I committed, right? So test commit. Hang on. So issues. Okay. I'm there. So say I'm coding on the Java backend. I just committed, saw an issue. I go to issues. I make a new issue, and I say it's too good. Okay, and then I can say da 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 da. Oh. I can say da 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 da. This is the problem. You can put pictures in here, links to stuff. You can embed videos, whatever you want to do. And then I can assign people to do it. So I'm gonna make Ben do it. And then what I can do is I can label it bug, document, all these different things, apply labels, attach it to a project, so Nate Nation. So all the bug fixes that are related to getting TCZ back up and running go to Nate Nation. Everything else is uncategorized. And we have a milestone that we are working towards, which I did not set, of just getting TCZ back up and running. I have yet to know the difference between a milestone and a project, other than maybe multiple projects can hit the same milestone. But you can post that review. So we're going to label it, we're going to attach it to the Nate Nation project, and we're going to label it a bug. Okay, follow me? So we submit an issue, we have an issue. Oh, dang it, it's an issue. So now what we can do is if we go back to this projects tab and go into Nate Nation, we should see it. Where is it? Oh yeah, we got it. Yeah, one new card. It's too good. So we add this card to our large capital list. And now this is a centralized location. So for you guys are all coding, you're pushing issues. I can just go to the projects tab and look and see and just go, oh, it's too good. What is this issue? Oh, it's me. And it's on the user interface repository, and Ben's supposed to fix it. So it's a really nice way. I'm going to close the issue and I'm going to drag it out. Can I drag it out? I'm going to remove from project. Yeah. This is a nice way for us to not only track issues, but to see what it needs done on everything. So one of the ways that I know that we are ready to go to TCZ is because I know from all these repositories that they all have issues that are not there. They've all been fixed. So I know that was a more dry workshop with not a lot of huge amount of general knowledge and a live demo, and it's a little bit more haphazard, but
Probably gonna let Mark just-
what'd you say? Yeah, you guys are gonna get way more out of just using it. This is something I want you guys to get more used to. A lot of you have GitHub Desktop downloaded, but I don't think a lot of you guys have actually had it, like you're using it frequently. So that is, I think I'm gonna end it there. If you guys have any questions, that is, yeah, that's GitHub for you. Very cursory overview. Dr. Fish, I hope that answered your problem. Yeah. No, don't clap for me. Oh, that's even